Okay, so let's focus on something else for now. For now, we will leave our T-Rex class as it is. We will revisit it later to implement what's missing. For example, there's no logic whatsoever attached to the speed property or the isAlive property, but we'll take care of that later. Let's focus on something else. And what I'm talking about specifically is, if we go back into our diagram here, is this entity manager. We do have an interface, iGameEntity, and our T-Rex class actually implements that. But what we're currently doing is that in our T-Rex runner game class, we just directly instantiate the T-Rex and keep it in a field of type T-Rex, obviously, and then just call the update method of the T-Rex directly in the update method of the game class. But instead we want to have the entity manager take care of updating and rendering all of the different game entities. So let's go ahead and create a new class in the entities namespace. Call it entity manager. Make it public. And now let's take another look in our model here. And yeah, let's actually design our class exactly as we planned it here. So first of all, let's add a new list, a new field of type list. And it can actually be read-only. There we go. And what the read-only keyword will do, it makes it so that it's only allowed to set this field either here directly like this, or in the constructor of the class, or in one of the constructors of the class. We'll just do it here as a field initialization directly. Let's take another look. Now we need to be able to add entities to the game. So therefore, let's go ahead. Actually, let me take another look here. Yeah, actually, let's go with the update method first. And obviously the game time class is in a different namespace, so let's add a using directive here. There we go. The same goes for draw. There we go. And in our update method, all we really want to do is call the update method of all our entities. So let's go ahead and say for each iGameEntity entity in entities. Whoops. In the for each loop, we're going to call, whoops, the update method of each entity. There we go. And for the draw method, remember that we that our game entity interface exposes a property named draw order. And we can use that to to determine which entity to draw first. So let's go ahead and in our draw method also add a for each loop. But instead of using the entities list directly, we're going to call an extension method from the link namespace named order by. And actually we have to add a using directive here, called system link. That's the name of the namespace. And now we can order the entities. We will order them by the draw order property. There we go. And order by will order them in ascending order. So that would mean that the entity with draw order 0 would come first, and then draw order 1, draw order 2, whatever. So it goes from low to high, from lowest to greatest. And I guess that's okay. Yeah, that's fine. And then we will just simply call the draw method of the entity, pass the sprite batch, pass the game time. And I think just to keep it consistent, let's actually switch these two arguments here like this. It doesn't really matter, but yeah. Okay, so we order the entities by the draw order and then call the draw method. So that's fine. What else? Yeah, we need to be able to add new entities. So create a new method according to our concept here. Add entity, and it will take the entity that should be added. Now, if someone tries to pass null here, we want to handle that as an and throw an exception, because it doesn't make sense to add null as an entity to the game, right? So if someone was to pass null, we don't just want to go ahead and add null to this list of entities. It doesn't make sense. So let's go ahead and go if entity equals null, or we could also say is null, throw new argument null exception, like this. And we all in the constructor of the argument null exception also accepts the name of the parameter that caused the exception. So let's go ahead and say name of entity, and maybe pass a message that says null cannot be added as an entity, or something like that. Okay, now the problem with this is we cannot just go and do this because in our update method we iterate over the collection of entities, and you shouldn't ever manipulate a collection that you're currently iterating over. So let's say we're currently in the update method and we're iterating over the entities, and we're now at the second element of the list, and a list contains, like, let's say 10 entities. And now in the update method of the entity, we actually we call the add entity method to add an additional entity to the list of entities that the entity manager manages. So that would directly influence and manipulate this list, but we're currently iterating over it. So that would mess up the iterator that the list provides for the iteration, and that would result in an exception being thrown. So instead of directly adding it to this list of entities, we will store it in a separate list first, and then after all of the entities have been processed, we will then safely add them to the collection of entities. So let me just go ahead and put it in code so you see what I mean. So let's go ahead here, private read-only list, and call it entities to add or something like this. We can directly assign a new list here to the field, that's fine. And then in the add entity method, we will go ahead and say entities to add entity. There we go. And then in our update method, after this for each loop here, we will add another for each loop and say oops. Like this. And then here, clear the list. So now, whenever someone calls the add entity method, they will pass a new entity that should be added to the game. But instead of adding it directly to the list of entities, it will be added to a separate list called entities to add. And then in our update method, after all of the currently existing entities have been updated, it will iterate over the separate list of entities that should be added and adds them to the other collection so that we don't manipulate the collection while we're iterating over it. And once we're done with that, we just clear this separate list so that, they're not added repeatedly in the next frame. So yeah, that's it. And we have to do the same thing for removing entities. So let's just duplicate this line and then rename this entities to remove. Like this. And again here, want to handle the case where if someone passes null and maybe, I don't know, null is not a valid entity, something like this, doesn't really matter, just to indicate that null shouldn't be passed here. And then here, entities to remove dot add entity, there we go, add it to this separate list field. And then in our update method, add another for each loop. I will just copy this here and change this to entities to remove. And then here, obviously, instead of calling the add method, I will call the remove method, like this. Okay. Yeah, let's take a look at our class diagram here. We also want to be able to remove all of the entities with a clear method, which I'm not sure we're even going to need, but let's add it anyway. And simply what this will do is it will add all of the entities that currently exist to the list of entities to remove. So entities to remove, add range, then pass the list of entities here. So this will make sure that all of the currently existing entities are added to the list of entities to remove, and then in the next update, in the next call to the update method, they will be taken care of here in this for each loop and will be removed from the list. So that should be fine. Let's take another look. What else? Yeah, maybe from outside of the class, we may want to access the collection of entities that is currently available. So let's add a property here, and it will be of type IEnumerable, because it doesn't really matter what type of collection it is. We just want to make sure that it is enumerable, that it's a collection that we can iterate over. And let's call it entities, and it will simply return I mean, what we could do is simply return the list directly, but that kind of sort of breaks the encapsulation here, because now the caller, the client of this class here, what they could do is simply use this property to access the list, which implements the IEnumerable interface, and then they could cast it back to a list and then manipulate it. The IEnumerable interface itself doesn't expose any methods for manipulating or changing the collection, but if the client of this class, the user of this class, just simply casts it back, downcasts it to a list, then they would be able to directly manipulate this list, which would possibly put this entity manager into an invalid state. So we don't want to do that, but instead we want to return a read-only view, a read-only version of this list. So what we can do is return a new read-only collection, and this is in a different namespace named object model, system collections object model. And in the constructor of this class, we can just simply pass the list. So we simply instantiate a new read-only collection. Oh, I need to specify the type. Like this. We create a new instance of a read-only collection that is basically a wrapper around our entities list, and return that as an IEnumerable to the caller. So now from the outside of the class, someone could do, yeah, I don't know, let's say someone instantiates the entity manager, and then they could do entities to get all of the current entities without being actually able to manipulate this collection. So they could do something like, I don't know, something like this, in order to iterate all of over all of the currently active entities. Okay, so what else? I think that's it so far. Right. Yeah, I think that's okay. So let's go back into the T-Rex Runner game class, and here add a new field of type entity manager. And in our constructor, we will assign a new instance of entity manager to this field. And now in our update method here, instead of directly calling the update method of the T-Rex object, we will say, whoops, entity manager update, and pass the game time object like this. And same for the draw method. We don't actually want to directly call the draw method of the T-Rex, but instead call the draw method of the entity manager. Whoops. Like this. And we don't, I mean, we can store the T-Rex here in a field, that's fine. But in order now to add it to the collection of entities that should be updated and drawn, we need to do one more step. Here in our load content method, we should here call the add entity method of our entity manager and pass the T-Rex. But we don't really need to store the T-Rex here in the field. It's not really necessary. But yeah, it doesn't do any harm as well. It doesn't really Doesn't really matter. So for now, let's keep it. Yeah, so if we play the game now, run the game now, it should still do the same. Yeah. It's still working perfectly fine. But now we have a generic entity manager, which we can use to add new game entities to the game. And they will all be automatically updated and drawn in the order that we specified. So that is fine. Okay, so actually let's go back into the entity manager, because I just realized that we forgot something here. We forgot to clear the list of entities to add. We do clear the we forgot to clear the list of entities to remove. So let's do that. Yeah, we can do that here. Like this. And now we're good. So, okay. Let's see, what else? So now we have the entity manager class, which we can use to add new entities to our game at any point in time. And the entity manager class will also make sure that all of them are regularly updated each frame and drawn to the screen in the order that we can specify ourselves. So what else? Let us take a brief look at our game again here. Yeah, so we can already do all of the moves. We can have a little T-Rex dance. Okay, and just to remind you, there's no script behind this video or anything, or too much preparation. This is off the cuff. I'm doing everything here off the top of my head. It's just really spontaneous. So excuse me if at some point there's some delay or stuff takes longer than it should. But yeah, let's just go ahead. Go into our diagram here, and let's see. What could we do next? Yeah, we need obstacles, we need the sky still, and we need the ground. And I think for now, the ground would be the most reasonable thing to do next, because that way we can actually see the movement of the T-Rex. For now, right now it just looks like it's running in place, or it really urgently needs to go to the bathroom or something. So let's actually take care of the ground, the floor, that moves across the screen. And if we take a look at our diagram here, at our class diagram, let's see. Yeah, we said that there will be a ground manager, which is also an implementation of iGameEntity. Let's see. Yeah, let's just go ahead and add a new entity. Let's go right-click on the entities folder here and say add class, ground manager, make it public, although that's not required, and it'll be an implementation of the iGameEntity interface. The compiler will complain because we don't actually implement, we're not currently implementing all of the members from the interface. So let's create a stub automatically using IntelliSense by hovering over the highlighted iGameEntity and say implement interface. The draw order may as well be a public auto property like this, and then we'll simply remove the throw statements here like this. And now let's see. First of all, we need, if we take a look at our sprite sheet here, down here is the ground. And for some reason, it starts 2 pixels in. So the start position of the sprite is not 0, it should be 2 for some reason. And let's see what its actual width is. Let me select this. Oh, this is going to take a while, isn't it? Okay, so the actual width of the sprite is 1200. Okay, so let's go into Visual Studio and define a constant and say sprite width 1200. Now what about the height? Should be 14, right? Yeah, seems about right. Whoops. Oops. 14. Whoops. Now that's great. We need a constructor. So I type ctor and tap twice. Then we need to pass the sprite sheet here. And what else? We don't really need to pass the position since it's fixed. Kind of. Let's say, let's add a, oh, right. Hold on, it's not just one sprite. We said that we will have to divide this into 2 sprites and randomly either spawn the left half of this giant sprite or the right half. Just completely randomly, so to bring some variation into the background. So let's go back into Visual Studio and actually say here 600. That's fine. Now let's create a field. Yeah, let's create a field of type texture. And call it sprite sheet actually. And in the constructor, we will assign the sprite sheet that was passed to this field. And that's fine. And then we need to spawn, basically, we need to create sprites from the texture randomly, kind of. So let's see, how can we achieve this? First of all, let's create a list, which can be read-only, of sprites. And sprite is defined in a different namespace, so we need to add a using directive, T-Rex runner graphics, there we go. Let's say ground sprites, something like this. And we can directly assign a new instance here. We could also do this in the constructor, like this. Oops. It doesn't really matter. Now, what else? Well, now we have a list of sprites. and we want to move the sprites across the screen. But first we need to instantiate them. We got to do that randomly. First of all, let's go back here and see the coordinates. Let's see what the coordinates, the start coordinates are. And I think it says it. Yeah, it's the x coordinate. It's down here actually. The x coordinate is 2. The y coordinate is 54. Yep. Like this, 2 constants for the position. That's fine. Now let's go ahead and we need to think this through. So take a quick look, and as you can see here, that the ground is, it appears to be, the pattern of the ground appears to be completely random. And it moves across the screen according to the current speed of our T-Rex. So the longer our game session lasts, the faster it moves. Let's minimize this, and yeah, let's see. I think maybe we should actually implement each tile of the ground as a class. Maybe we should define a new class like ground tile. And that class would have a position property that we can manipulate using the ground manager. That would be an idea. I think that's actually not a bad idea. So let's just go up here. We don't need to do it in a separate file. We can later move it to a separate file. Say public class ground tile, which is also a game entity, or it doesn't really need to be a game entity. No, we just need to store the position and the sprite. So let's add a property here. I'm just gonna go ahead and type prop and tab twice, and it will be of type vector2, and it will be the position. And then have a sprite property, which doesn't need to have a setter. And then we need a constructor, or actually we can remove this and simply highlight these 2 properties, right click, quick actions, and then select generate constructor, and it will automatically generate a constructor with these 2 properties, or for these 2 properties here. And yeah, looks great. And yeah, all I really need this class for is so that we can associate a position with the sprite, basically. Yeah, so let's go ahead, and instead of having a list of sprites here, let's actually make this a list of ground tiles, like this. There we go. And now let's see what else. I got an idea. Let's actually make the ground tile an implementation of iGame entity. Implement the interface. Draw order will also be here a auto property. And the update method in this case won't do anything for now. And the draw method will simply draw the sprite. Sprite draw pass the sprite batch and the position, like this. And yeah, what else? Maybe. I mean, the only maybe we don't need a position as a vector too. I mean, the only it only moves on one axis, right? The y position, the position on the vertical axis doesn't ever change. So yeah, so let's just say prop float, a public float property, and call it position x. Like this. And then add a field named position y, and add this to the constructor as well. But you won't be able to change that. And here we simply pass a new instance of vector2, which will consist of the position x and the position y. Now, the position y is a fixed value. It doesn't ever move on the y-axis. So let's go into our ground manager class and here define a new constant of type float and call it ground tile pos y. And yeah, let's see. Yeah, let's just use 164. Yeah, should be fine. If not, we can adjust it later. So yeah, and hold on. Yeah, that's fine. Update won't do anything for now. I don't think it will ever really need to do anything. And that's fine, I guess, yeah. So let's right click the ground tile class name here and say quick actions, move type to groundtile.cs. So that way it will automatically be moved to a separate file here. Just so that it's a little more organized. Now, let's see. In our update method, I got a good idea, yeah. Okay, in the constructor of the ground manager, let's actually pass an instance of the entity manager and store it in a field. Like this. Could also be read-only, would actually make sense. Let's make it read-only. Well, you don't really need to. So now we can pass an instance of entity manager to the constructor of the ground manager. It'll store it in a field. And then in our update method, let's see. Now let's go ahead and create two methods. First of all, two private methods that are responsible for creating either the left half of the ground as a sprite or the right half. So let's say private ground tile, create, let's say create regular tile. So we will refer to, we will refer to, minimize this. We refer to the non-bumpy part of the texture to the regular tile, and the other one will be the bumpy tile. So let's go back into Visual Studio and do that. We will create a ground tile. And let's actually here pass the X position, and the Y position will always be the same, and we already defined it as a constant. Like this. And we need to pass a sprite. We can actually reuse the same sprite over and over. We don't need to create one individual sprite for each tile. We can just create, pre-instantiate the two sprites and then reuse them. So let's go ahead, create two fields. Whoops. There we go. Say regular sprite, and another one bumpy sprite. Bumpy. There we go. Then in the constructor we can say regular sprite equals new sprite. The texture will be the sprite sheet. The X coordinate is sprite pos X and sprite pos Y and sprite width and sprite height. There we go. And that should be right. And the bumpy sprite, we will also instantiate a new sprite, but the X position needs to be adjusted. We just simply need to add the sprite width here. That should be all right. Now, in our method, create regular tile, we are simply going to here in the constructor pass the regular sprite like this, and then return that tile. And copy this method, paste it, and rename it create bumpy tile, bumpy. And here we will pass the bumpy sprite instead. Yeah, looks good. Now, let's go ahead and create a new method and call it initialize. And this method should be called by our T-Rex runner game class. This one, T-Rex runner game class, in order to create the first instance of the ground here when the game starts. Whoops, yeah, that's right. Close the debug window here. So let me actually refresh this here, and so basically when we initialize it, the first ground tile should already be spawned. There we go. And I think the first tile that is created will always be the regular tile. That will not be random. So let's go ahead, say ground tile. Yeah, ground tile is okay. Equals create regular tile. And the position would be, in this case, 0. And let's add it to the list of ground tiles. The list is actually still named ground sprites. Let's actually right click it and say rename ground tiles. So now the field has been renamed ground tiles. Say add, and add the ground tile that we just created at position 0. And let's also go ahead and use the entity manager to actually add it to the game. Add entity ground tile. There we go. And what else? I think so far we can already test this. Let's go ahead, let's go into our T-Rex Runner game class. And yeah, let's go ahead and create a field. A private field of type ground manager. Call it ground manager. And in our load content method, after instantiating the T-Rex and the input controller, let's go ahead and instantiate the ground manager and pass the sprite sheet as well as our entity manager. And now let's just, for testing purposes, right here in the load content method, call the initialize method of the ground manager. Yep. And let's test this. Should actually render a ground tile now. Or maybe not. What may be the reason? Let's go back into the ground manager class. So let's go into the ground tile class. Let's put a breakpoint here. I want to know if the draw method of the ground tile is actually called. Yes, it is. Maybe the position is not correct. Yeah, the position, okay. I goofed up here. The window is only 150 pixels in height. So how can the start position of the ground tile be 164? That doesn't make sense. It should be something obviously that's less than 150. Yeah, that was stupid. I guess the screenshot that I took was kind of zoomed in, so that's why. Yeah, sorry for that. That was stupid, but okay. Let's go into the ground manager then, and obviously the ground tile position is not 164, but let's say it's 142. Let's test this. And remove the breakpoint here, say continue. And there it is, there's the ground, but it's still too low, so let's move it up a little bit. Where is it? Ground manager 130, maybe? Oh, still too low. Let's say 120. Still, I think it's 1 pixel off. Let's say 119. Yeah, that seems right. So now if I press up, yeah, obviously it doesn't move, but it is drawn properly.